Now let's do the next problem using Thevenin's theorem. Okay, so here the question is, in the given network, find the current through the 10 ohm resistor. Okay, where's the 10 ohm resistor? Here. This is the 10 ohm resistor. Okay, so the question is, find the current through the 10 ohm resistor. So which means, since they have said find the current to the 10 ohm resistor, then the 10 ohm resistor is the output device, or in other words, the 10 ohm resistor is the load, which means that is the resistor you need to remove. Okay, so that's what it means. Which element they have across which element they have asked you to find the value, well, let it be the voltage through that element, or let it be the current through that element. That element will be the load, so you need to remove that load. So here this 10 ohm resistor is the load, so you have to remove that load. So therefore, removing the 10 ohm resistor, removing the 10 ohm resistor, comma, the circuit now is this resistor and this capacitor over here, and this voltage source over here, this resistor, another resistor is over here, another voltage source over here, and another resistor is over here, and this point. Okay, there. Now I have removed this 10 ohm resistor. The rest of the circuit is the same. Okay, 2 ohm, this is 10 angle 0 degree volt, and this is 5 ohm, this is 1 ohm, and this is minus 2J. Okay, now what I'm going to do is, as usual, I am going to apply mesh analysis. Okay, I'm going to apply mesh analysis, and by applying mesh analysis I will find the value of VTH. That is what I'm going to do. Okay, so since this is the branch you have where you have removed that load, therefore the branch is open, which means the current through that branch is 0. And what is the current through that branch? If this is I1, then this is I2, which means the current through this branch is I2, which means the value of I2 is equal to 0, right? Because mesh 2 is open, therefore I2 is equal to 0, right? So therefore, let me mark the mesh currents. Okay, I1. Okay, I'm now going to mark I2 over here because I2 is equal to 0. It's actually wrong to mark the mesh current because this is not a mesh, right? An open loop is never a mesh, right? So therefore I'm not going to mark. If you are very tempted to mark I2, then if you're marking, then draw the arrow and then write I2 is equal to 0. Alright, otherwise the examiners will get confused and they might cost you some marks. Okay, if you make that kind of mistake, that's why I'm hesitated to mark I2 over here. Okay, but I'm going to write the statement that since mesh 2 is open, comma, I2 is equal to 0. I will write the statement. So this will remind me that to substitute all the values of I2, wherever I see the value of I2, I'm going to substitute that value as 0 after applying mesh analysis. So here the equation for mesh 1 is, equation for mesh 1 is, okay, so what is the equation for mesh 1? Here I1, right, it is touching which all elements it is touching? Let me see, the polarity of this question is like this. Okay, plus minus, okay, that is the polarity of this voltage. That you need a polarity, right, when you're going to mark the I1. So here I1 is touching this 1 ohm, this 5 ohm, and this minus 2J. So what is 1 plus 5? 6. So you have 6 minus 2J. Okay, 6 minus 2J. I1 is touching 6 minus 2J minus I2 into, and this I2 is touching only this element over here, right? This 5 ohm. There you have it, is equal to, and the voltage source is in this direction, right? This is 10 angle 0, but this current I1 is flowing into the positive terminal, which means this positive terminal is not generating I1, it is opposing I1. Usually the positive terminal of a battery is supposed to generate current, but this is not generating current, this is opposing current. Therefore it is minus 10. Minus 10. 10 angle 0 is 10 itself. Okay, so it is minus 10. So this is the equation, but since I2 is equal to 0, which means I can now mark this as 0. So therefore the equation is I1 into 6 minus 2j is equal to minus 10. Or in other words, I can find the value of I1 directly, right? Very easy. Now I can find the value of I1, that is minus 10, 6 minus 2j. That is the equation for this one. And what is minus 10, 6 minus 2j? Let me see. Minus 10 divided by 6 minus 2j. Okay, and you get is minus 1.5 minus 0.5j. This is equal to minus 1.5 minus 0.5j minus 0.5j. This is the value of I1. Okay, so now I am going to write the equation for mesh 2, or not the equation for mesh 2, the equation for VTH. Therefore the equation for VTH. Okay, equation for VTH is just simply hypothetically assume that you are writing the equation for mesh 2. Okay, so which means according to here, since I2 is positive, I1 is negative, so it is minus I1, and in this mesh I1 is touching only this element, right? What is the name of this element? 5. So minus I1 into 5 plus I2 into, and what about I2? I2 is touching this 5 and this 2 over here. So 5 plus 2 is 7, right? So it's touching the 7 over here. That's it, right? It's no other element over here. Is equal to, and as far as the voltage source is concerned, this I2, right, it is flowing in this direction, right? It is flowing in this direction, right? So in this direction means this, it is going upwards. Upwards means then this positive terminal of this battery is generating I2, right? Because the current is, I2 is flowing upwards. I2 is flowing upwards. So therefore this positive terminal is creating current, or is generating current, or it is supporting current. So it is plus 10. Okay, 10. And the same I2 is flowing from left to right. It is flowing left to right, which means it is flowing into the positive terminal of 5 angle 30. It is flowing into the positive terminal, right? Which means this positive terminal is not generating I2, it is opposing I2, right? So therefore it is minus 5 angle 30. Minus 5 angle 30 degrees. Okay, this is it. Now, but I2 is equal to 0. Oh yes, I forgot, it's plus VTH, right? Plus VTH. Oh, I forgot that. Plus VTH. Why? Because there is another voltage over here, right? And the name of that voltage is VTH, right? Voltage drop. It's a voltage drop, right? This is the higher potential, this is negative potential, and this current I2 is actually flowing from a higher potential to a lower potential. So it is plus VTH. Okay, I forgot to mark over here. It is plus VTH over here. So now I2 is equal to 0, right? So therefore it is minus I1 into 5 plus VTH is equal to 10 minus, what is 5 angle 30? Let me see. 5 shift angle 30 is nothing but 4.33 plus 2.5j. 4.33 minus 2.5j. Correct, na? 4.3 minus 4.33 minus 2.5j. Okay. So therefore VTH is equal to, now let me see what is 10 minus 4.33 is equal to 5.67. This is 5.67 minus 2.5j plus 5i1, right? Plus 5i1. It comes over is plus 5i1. But we all know what is i1 is, right? 5.67 minus 2.5j plus, and what is this? 5 into what is I1? I1 is minus 1.5 minus 0.5j. Let me write that over here. Minus 1.5 minus 1.5 minus 0.5 j. Okay, or this is equal to, let me substitute the values, 5.67 minus 2.5 j, okay, plus 5 into bracket minus 1.5 minus 0.5 j. Close the bracket again. This is it, right? 5.67 minus 2.5 j plus this one's value, and you will get is minus 1.83 minus 1.83 minus 5j. Minus 1.83 minus 5j. Okay. Let me find its polar value. Options 1. Oh my goodness. Minus 1.83 minus 5j, right? Minus 1.83 minus 5j. Options. Oh, thank goodness. It is 5 point, yeah, correct. It is 5.324 angle minus 110.103 degrees. The answer is correct. That's why I was worried if the answer is correct or not. So this answer is correct. This is the equation for VTH. This is the value of VTH. Now I'm going to find the value of ZTH. Okay. So to find ZTH, comma, to find ZTH, what you do is, here you can see that there is only two voltage source over here, right? So what you do is you simply short these two voltage source. There is no current source, so only voltage source are here. So just simply short them. So therefore your circuit diagram will become like this. That is, first it will have a resistor as usual, then it will have a capacitor as usual, then this is shorted, right? So there will be a single 5 ohm resistor, right? It will be a single 5 ohm resistor. Then here also this 5 volt is also, this 5 angle 30 is also shorted, right? So therefore only a resistor is left behind, right? Only a resistor left behind. That's all, right? Only this much element is there, right? Only this much element is there. So which means find the ZTH over here. Okay, find ZTH. This is 1 ohm, this is minus 2j, and this is 5 ohm, and this is 2 ohm. Okay, so now I'm going to find the equivalent impedance, right? Alright, so the impedance between A and B. So here you can see that these two impedances are parallel to each other, right? Or in other words, what is the value? That is 5 into 1 minus 2j divided by 5 plus 1 minus 2j. Z1, Z2 by Z1 plus Z2, right? This is these two elements combined together, you get 1 minus 2j, right? You don't have to draw that. So it's 1 minus 2j. So it is, so if I combine these two, since these two impedances are parallel to each other, therefore it is 5 into 1 minus 2j and 5 plus 1 minus 2j. You will get over here as 5 minus 10j by 5 plus 1 is 6 minus 2j, which is equal to, let me see, 5 minus 10j divided by 6 minus 2j. Okay, and you will get is 1.25 minus 1.25j, which means your new element will now, it is like this, and the name of this element is 1.25 minus 1.25J, and this is nothing but your resistor, which is 2 ohm. Okay. Okay, and as you can see in this diagram, these two impedances are series to each other, series, right? Why the series is because if a current is flowing through from A to B, if a current is flowing from A to B, the same current goes through this 2 ohm and that same current goes through this impedance, which means if the same current flows through both the elements, then those two elements are in series to each other, right? So therefore ZTH is equal to 2 plus 1.25 minus 1.25J, 1.25 minus 1.25J, which is equal to 2 plus 1 is 3, right? So 3.25 minus 1.25J. This is the value of ZTH. Or in other words, ZTH is, let me see, it is 3.25 minus 1.25J, right? 3.25 minus 1.25J, and this is option. I'm going to convert this to polar form, and you will get the answer as 3.482 angle minus 21.038, correct? Minus 21.038 degrees ohms. This is the equation for ZTH. Okay, so therefore your equivalent circuit is this one, that is a voltage source with an series impedance over here. Okay, and the equation of this is VTH, and this is ZTH, and what is the value of ZTH? It is 3.482 angle minus 21.038 degrees. Okay, and over here it is VTH. What is value of VTH? VTH is 5.324 angle 110 point is minus 1.103, minus over here, right? This is minus 1.103 degrees. Okay, and now the question was find the current through the 10 ohm resistor, and that 10 ohm resistor you removed it, and the remaining circuit you converted to its Thevenin's equivalent. So now what I'm going to do, I'm going to put back that resistor to its place. So on putting back the resistor, right, this entire network, right, this entire portion, not touching the 10 ohm, this entire portion is now converted to its Thevenin's equivalent, that is a single voltage source with a series impedance. Now I'm going to put the resistor back to its place, that 10 ohm, that same 10 ohm resistor, that load which you have removed before, that same load I'm putting it back to its place, and now I'm going to find the current through the 10 ohm resistor. That is the question, right? Find the current through the 10 ohm resistor. Okay, so how do we find the current? What is the current through the 10 ohm resistor? Current through the 10 ohm resistor is nothing but, let me see, that is I, this is ZTH and this is 10 ohm, right? So I into ZTH plus 10 is equal to VTH. This is the equation, right? According to the mesh analysis, if you apply mesh analysis over here, I into ZTH plus 10 is equal to VTH, right? Or in other words, I is equal to VTH by ZTH plus 10. Okay, I think it's better you use the rectangular form, right? Better than the polar form, it will be the rectangular form. Then you can finally convert the, so what is the rectangular form? It is minus 1.83 minus 1.83 minus 5J. That is the value of VTH by, and your ZTH is this one, right? 3.25 minus 1.25J plus 10. Okay, so therefore the current is, let me see, the numerator is minus 1.83 minus 5j, okay, minus 1.83 minus 5j divided by, and the denominator is 3.25 minus 1.25j plus 10, close the bracket. Let me check if I have typed correctly. The denominator is 3.25 minus 1.25j plus 10, and the numerator is minus 1.83 minus 5j, okay, and you will get the answer as minus 0.102 minus 0.387j. That's the current. Okay, now in other words, the current value is changing the answer to its polar form. Okay, it is 0.4 angle minus 104.713 degrees amperes. This is the current through the 10 ohm resistor. Current through the 10 ohm resistor is equal to this value. Okay, let me see if the answer is correct. Yeah, it is correct. Okay, this is correct. So this is the answer. Okay.